that for the most
So
part.
I did prepare a package of the creation of the Hydra sequencer, if we wanted to talk about that. But we would have to start with explaining what was the problem in the first place that we were trying to solve. Do you know what that problem is, Jake, or are you too busy watching Reese?
Oh no!
Wait, did he hang up?
Last comment. We should really dub over
he might
somebody
have
else
hung
talking during this thing.
Sorry.
Weasel, when you want to come back and scream, wave your hand so we know to unmute you. Okay. Oh, he's still yelling. Okay.
Red in the face yelling.
Why am I upset that you're calling me? Because fuck
who
you.
unmuted him? I didn't do it.
You did that again?
Jesus Christ!
You did.
I
did not do that. Okay. Now, Hydra sequencer. Let's go over this.
What was the
Perfect
problem
segue.
that we were solving?
The problem was we have a couple sets of valves that need to turn on, and then the other ones need to turn on. When we didn't have the sequencer, they all started moving at the same time, okay? But as they were moving, fluid was traveling in one open one, through, and then back through the other open one. We need to make sure one was closed first before we could actually start moving the second set.
So like a water faucet with handles, right? If you were considering them binary, either on or off.
Right.
But
there is
transitional
time
state.
between like 50 milliseconds to 150 milliseconds, which doesn't seem like a lot of time, but you can, when the flip is only 100 milliseconds total, you get a lot of overlap and a lot of run through when the pressure goes right back to its existing tank. So Dick made this sequencer, testing out Go ahead. You explain.
This was the first sequencer. This is the rawest version. When I thought we only needed 2 switches. So we've got 2 FET switches there in this first one. And it would have worked, but they really needed 3 switches. So then I switched to this design, which is the first board I delivered to Jake. And this has a lot of problems, which I'll explain later. But this actually did work. This would work just like this. So there's 3 switches for the three different valve clusters. So there's two valves that hold it in the down position that need to be switched so that it closes off the back to tank first. And the second one and the third one are the low flow and high flow valves, right? Isn't that what we're talking about?
Correct.
So this actually did work. This would work like this. But the problem is that there's no protection on this. This is wired directly to the valves and directly to the receiver. So this is a vulnerable piece of equipment in this state. So this is the new one. On the left, under the 820, these are all the opto isolators to essentially decouple it from the receiver itself. And the A, B, C, D, E, F, G, H, I put on 2 extra switches. There's really 6 valves in Hydra. They're in sets, so A, B, C, D, E, F. And this is for in case they decided to come back to me and say, "Oh, we need 2 more," which I wouldn't be surprised if they would have done to me.
We usually do that to you all the time.
Yeah. So this is, and then I removed the load switch, essentially the switch that switches the valve. This is what I call the smart switch. The switch on the top, the valve is up here, and on the bottom is signal from the board and battery power. So these are used today in Hydra. These are the 2 boards on a credit card because in bots, smaller is better. This is the populated board. This is the populated board. Yeah, the lower the mass, the less you'll inflict damage upon it due to G loading. Like Hydra has a tremendous amount of G loading that it creates on itself. So when it fires, it's
what is it?
Crazy.
Do you know the number?
No, I don't.
It's at least 100 Gs.
And what's fatal for a human?
10?
10, yeah. So the receiver is coming in on the right. It's opto isolated, or I'm sorry, the receivers are coming in on the left. That's why he needs that radio with the extra 3 channels. This could have been done with 2 channels, but that would have made it harder to manipulate. We'll see that in a minute, how he runs it. The opto isolators are up here on the left below the three LEDs. The 3 LEDs are essentially the state mode states, and then A, B, C, D, E, F, G, H are just fancy fun things. They don't even need to be here, but they're just indicating which valves are currently activated. This is the programming, the command line interface, essentially how you adjust the things. And at first we had the this caused me probably 20 hours of programming. You had a valve that was in the wrong state, right? The non-powered state was backwards, so you had to have a valve powered all the time. Remember that?
Yep.
Yeah, the original valves were the wrong valves, and we had to hold them actually powered the whole time while the bot was not in flipping stage.
Right. So this added an extra 20 hours of programming to get this switch invert, and you can see down here in the under the version number where it says Watchdog Timer. That means if it should fail in any way, it'll reboot instantly. Not switch direction. That's always set now because they've fixed this problem with the thing, and that takes out all of the code for switching the stuff. Serial terminal, not debug, because you don't want your debug running while you're in production. So that's what this is here.
Very good.
Yeah. And this is the test video I sent the team showing how the switches are working. You can see on the left is the mode state. I'm using fire on the right stick. Jake, you do something else. What do you do for your fire command to fire?
My left stick is my forward reverse kind of thing. And then if I hold right, it starts engaging my slow mode. And if I just want to fire, then I actually hit the trainer button on top of the screen.
Yeah, so this is exactly the same as what Jake does, only instead of using a button, I'm using the right stick, which is normally his drive stick. So all the way down and centered. See, this is where I could have used one stick. You could have had all the modes on the center stick, but then you would have had to have that stick in certain positions all the time for it to work right. This way,
you don't want to do that while you're driving.
Yeah, this way, if he pushes over like I'm pushing on my thumb now, that is engaging the control mode. The up, down, you can see the modes of the valves switching as I'm moving it. So you can go up slow, down slow, because the top two, there's only 4 lights lighting up. Those are all the low pressure valves. The high pressure max flow valve is not firing. Now I can fire from any position. So he could be control moding and go, oh, here's a flip, boom, flip, right out of that mode. And that was a little bit extra because I didn't want him to hit the button and never have it fire.
We're gonna do a quick unmute here.
Okay.
Just maybe you can't unmute because your guest. Oh, the guest, he muted himself because he didn't want us to hear it now. So sorry, folks. He actually muted himself now.
Why's up?
So during the programming, I realized if Jake hits the button and he's fiddle fucking around with these other control modes, that means he wants to fire. So it'll fire out of any of these control modes. If he's trying to bite them or trying to hold the flipper down or hold it midpoint, because he could hold the flipper tip in midpoint. In fact, you can see control mode.
Maybe it's because they knew you'd be a fucking.
Oh, I'm glad I caught that.
It's because I was.
Hey,
And we're off to the air.
what's going on?
No.
Okay.
See, I must have clicked it, but then he muted himself.
Okay.
So when he unmuted himself, then it kicked back on.
Okay. So you can see I can fire out of any of these modes. This is when I first delivered it. The problem we were solving is it couldn't fire twice without running the pump. Like Hydra should be able to fire twice in rapid succession. So that's what this test is. It just fired. It's going to come down, no pump, fire again. So here it is in the bot. You can see he's screwing around with the control modes. That's a fire. That's a fire. And there's the smart switches wired into the bot. So the valves wire into the smart switch. The smart switch then wires into the control. And here he is operating the slow mode. So he could just hold it down, it would bite.
So I
There's a
can
fire.
control bot like I did for Tantrum that last year. I did bite their spinner. Nobody counts that one though.
So that's pretty much it. That's the Hydra control.
I think I asked this question in person, but I don't think I asked this on stream. Like with the hydraulics, is there a reason that? And I think we kind of talked about this too, and I think I know the answer. But is there a reason that like a reverse Hydra, so to speak, like a hammer with the hydraulic slam, wouldn't work? Like, is it just like? Because I know hammerbots already have a hard time kind of like staying on the ground when they're swinging. Is that the main reason, or do you think that would potentially?
This is an engineering thing. Let's let Terry deal with this. Why would Hydra as a hammer not be effective?
We could mount a hammer right onto the flipper, sticking out the back. It would be a hammer.
It would be a hammer then, yeah.
Like, do you think it would be stable enough, or do you think it would just cause more problems than it's worth?
It's the swinging mass that's going to cost you. No matter what, the actuation's still doing it pretty much plenty fast enough. 100 thousandths on the swing. It would do it. It's just how much mass is out there and how much would the bot kick. Right now, it doesn't have a lot of mass on this flipper, so...
I was watching a video from Team Small Robots about Banshee and the problems they had this season. And one of them was that they, if you're more than 400 PSI, you have to test. You have to do, what is it, hydrostatic? Whatever. I'm not an engineer. I'm just gonna
you got to get them tested for their current ratings and have so much of a safety factor over top of their rated set.
Yeah. They tested they said their safety factor that they normally did and they did prior to BattleBots was 150%, but apparently BattleBots expects 200%. So they had to drop their.
It's pretty standard, isn't it, Pa? To have at least that.
Well, maybe
or even more.
Maybe for accumulator tanks, other pressure tanks, but I mean your valves are typically good to 5,000 psi, so that's not double.
So your internal pressures, 2,500 then?
3,000.
3,000. Oh wow!
And as far as this question about biting down, Jake did that just to placate me because I'm so sick of people saying that Hydra can't bite. Because I'm trying to explain. Listen, it was biting in the tantrum fight, and the move was brilliant. It's just it didn't work. He bit them, held them, got them in the corner. Let go, turned, went down, went under, flipped. I mean, that was just flip out opportunity, but it didn't happen.
Actually, it did work because their spinner didn't spin anymore.
Because of area difference between the cylinder on the rod end and the blind end, the biting is only about 700 pounds.
Mm-hmm.
So you're not going to crush. You're not going to crush with it, but you're going to definitely hold them.
Right. Pinch a finger off.
But it's like I did a lot of work. I mean, there's hours of work in being able to slow mode that thing, and it's just like
just wanted to see it.
I just wanted to see it in a fight, and then of course he didn't bite the tire. I should have said bite the tire, because then he could have dragged him around.